Gonna make this place your home.
Good morning and welcome to The Real Estate Show. This is Marcia Talbot and
You're here today with Christine Koenig of
there
Better
she
Homes.
is, and
Hi.
she's so good.
It's nice to be here with you, Marcia, and I'm super excited. Today we have a guest. Her name is Jamie Bogert, and she is with Alpine Air Heating and Air Condition. We are going to talk a little bit with Jamie about heat pumps. And by the way, you can see all these signs around town now about Heat Smart, which is the program that the state is
funding
to sort of drive people towards some different ways of heating your home. And it's not different, and it's not really old. It's not new, but it's just not what we are used to. So why don't you tell us a little bit about what exactly a heat pump is and some of its wonderful benefits?
Sure. Well, number one, thank you. I really appreciate you guys letting me be on. And the Heat Smart program, so Alpine Air was selected as the contractor for both kinds of heat pumps, a highly energy efficient heating and cooling system. And the goal is, New York State is really behind energy efficiency, reducing our carbon footprint, reducing our reliance on fossil fuels. And this is how they're doing it. They're funding programs like the Heat Smart Warwick program throughout the state. They have a lot of incentive programs I know you talked about before. And so the part that we're involved in is the heat pump portion. So a lot of people know about boilers and furnaces and central air conditioning systems. And even a high efficiency model would say, let's pick 85% efficient, which means every dollar of fossil fuel you put in, you get about 85 cents back in equivalent heating. So what we're basically doing is we're using a fossil fuel to heat the water or the air that's heating our home. Technologies have come out, and as time has gone by, they've become far more efficient technologies, and those are heat pumps. So there's two different types. There's air source heat pumps, which are more commonly known as ductless systems or mini splits. And then we have ground source heat pumps, which are more commonly known as geothermal systems. And geothermal has really been getting a lot of press lately, but a lot of people don't know what it is.
Right.
So basically, all the difference is instead of burning a fossil fuel to heat the air in your home or the water that heats your home, we are extracting the heat from either the air or the ground around us. Even in the wintertime, there's some sort of heat in the air. So we're capturing that heat and transferring that heat into your home. So instead of just generating our own heat, we're trying to capture as much as we can. And the same thing with air conditioning. These systems run in reverse, and they can actually offer air conditioning as well. And so what we do is we take the heat out of the home and dump it back outside. To make up any extra heating or cooling they need, they use electricity, and they're extremely efficient, so they use a much less amount of electric. And if you're able to get on a community solar array, or you can put solar or wind power in your home, then it's that much cleaner.
Right. I've been working with these guys to try to figure out what is the best solution for my home. So I'm still torn whether I'm going to go with the geothermal system or the air source system. One of the things when you say mini split, and let's talk about that, right? So a mini split is when you walk into your room and you kind of see there's like that white box up on a wall. However, there are some systems, and I do want to qualify because some people don't like that. Aesthetically, it's not what they want, like me. But you guys did come up with a solution for me.
We do. So the mini splits, the nice thing about, as technology progresses and they come up with more options, there are floor mount units that are similar size to like the old radiators that you used to see. They look a little sleeker. Those fit in some areas. For instance, we have a sunroom that we ended up insulating, and during those fall and spring times when you want to use that room, but it's not quite, good by itself.
Right.
We have a unit in there that's auxiliary. And they also have ceiling cassettes, which they stick out from the ceiling very minimally.
And so they're very narrow.
They're very narrow, and they're up in the ceiling where most people wouldn't notice them.
Right.
And then they also do make ducted models now. So depending on the home and the situation, that's an option, so that you have just your standard grills in the ceiling that you're used to.
Right. I think that's the option we're looking at right now.
Right. And so, there's an outdoor unit, and then that's connected to your indoor units throughout the home. So we talked a little bit about traditional units being, even the high efficiency models are generally under 100% efficiency. So we compare that to an air source heat pump or a mini split ductless system. And those are in the range, depending on the unit, in the range of 250% efficiency. And a lot of people say, well, how can you be over 100%?
That's correct.
Yeah. So we're taking the heat in the wintertime, we're taking the heat out of our ambient air that's around us, and we're, putting it back into the home. So we're not necessarily generating that heat. And then the amount that we need to generate to make up any difference, we're doing it with electricity. It's far more efficient. So basically, for every dollar of electricity you put into the unit, you're getting, $2.50 worth of heating back is kind of a way to think about it. Also, a lot of people don't know that those air source heat pumps can actually, depending on the model, they can actually go down to negative 15 degrees, the outdoor unit.
That was one of my questions.
Sure. So we can use them as your primary heat source, your only heat source. Some people choose to have a backup. It really depends on your situation. But those units are great for a full whole home system, we call it. They're great for, I talked about using it, we have one in our basement, we have one in our sunroom, even though that's not our main source of heat in the rest of the home, because those were afterthoughts in the house.
Right.
We finished our basement later, and the units that we had would need to be upgraded to handle that extra capacity. So we put, a ductless system downstairs to take care of that space for us. Sometimes if you didn't have air conditioning, especially, and you don't have a lot of ductwork, or if you had forced hot air, the ductwork is generally on the floor for heating and the ceiling for air conditioning. So that's a great time for heat pumps, air source heat pumps, because we don't have to run ductwork. If it's an older home, sometimes it's really hard to find space, or it's hard, you don't want to open walls and things like that to get the ductwork in. Actually, that brings up another thing is we do have a lot of customers that call and they say, I have an older home or I have an existing heating system, but I don't have air conditioning and I want to put in central air. And we say, well, if you're using oil or propane or even natural gas, or, they're fossil fuels that we're trying to reduce our greenhouse emissions and our reliance on fossil fuels. And also they're costly. And the prices go up and up and up every year. So your usage, your utility bills, you can't really predict them in the next, future years. So we talk about, well, if you're looking for air conditioning, you can put in an air source heat pump and you'll get your air conditioning. But oh, by the way, now you can use that as heat. And if your current system is not that old, that can be your backup, or that can be some auxiliary on those days where you might really need it. But you're limiting your use of it to help maximize your savings and reducing your utility bills overall.
So we've been talking a little bit about the air source. Let's talk a little bit about ground source, also known as geothermal, because I think that is what people hear more. I've heard for years when you're building new, geothermal is that is the time to install geothermal, because everything, through the construction process, it's an easier time. However, I've been doing more and more reading about retrofitting for geothermal. I guess maybe they've developed better techniques of doing that. And then with some of the incentives offered, it becomes a little more cost effective to do that. So can you talk a little bit about what ground source is, how it works, and what a homeowner should really know about that?
I can, definitely. Geothermal has really become a term that people are becoming more familiar with, but there's still a lot, what is it? I don't understand it. And again, we're using the ground as what's called a heat sink. There's underground, below the frost line, the ground is a more consistent temperature throughout the year. So there's always heat in there that we can capture in the winter and then, use it to heat our home. And in the summer, when the ground is cooler underground than our ambient air temperature, we can take the heat out of the home and deposit it back in the ground. So we're just using the ground as a way to capture or release, heat. They are range, roughly 500% efficiency, if you think of it that way, because for an air source heat pump, you're using the air, and obviously there is heat in the air in the wintertime, but there's less of it, whereas the ground temperature is much more stable throughout the year, so the average efficiency of the system is much better. Right. There are two different types of systems. There's a horizontal and a vertical system, and basically the difference is how we're using the ground. So similar to how you might have a well drilled in your home for your water, we can drill wells, vertical wells, and that's in a situation where they are a little bit more efficient. And if you have limited, yard space where you can actually have the outdoor part of the system, that gives us a smaller footprint. And so it's a closed system. It's not using the actual groundwater, but we dig into the ground, vertically, and we have pipes that we put in that go to and from the house. And then there's a horizontal system, which is we dig a long trench, and we have they're called slinky loops, or we geothermal loops, and it's a black pipe that's sort of spiraled that goes horizontally about 7 feet, 6-7 feet underground. And that's why you had mentioned it's a great time during new construction, because the yard's already ripped up, the excavator's already there. But depending on your yard and how much you're willing to have disrupted, either system can kind of be put in later.
Is there one that's more cost effective to do than the other?
Vertical is more expensive, just by nature of bringing in a well driller.
Right.
But it is a little bit more efficient, and there are some benefits. We can reuse existing ductwork. We can do, if you have radiant in your home, we can do that. So it's more of a replacement of your existing system. The nice thing about it is it also provides heating and cooling. And there's one indoor unit usually located in the basement, and we don't have that outdoor unit. So compared to an air source heat pump, or compared to like a central air conditioning system where you have that condenser outside, we don't have that. So the life expectancy of those systems is a bit longer, because there's no part of the unit that's open to, outdoor. The elements, yeah. Right. And the most expensive portion is the outdoor trenching or wells. And that part of the system, is expected to last like 100 years. So even if you have to replace your system in the basement, you're not having that same upfront cost again later.
What is the life expectancy of that equipment?
10 to 15 years. That's like the life expectancy. Usually the warranties are 10 to 12 years on those systems. The most important thing for any system, no matter high efficiency or not, is who installed it and how it was installed, and proper maintenance. You would never buy a car and never get the oil changed. So just because you bought something that's really efficient for the home doesn't mean that it's going to continue if it's not running properly, it's dirty. Again, it's exposed to the elements. You have power outages and things like that. So, use a reputable contractor, get it designed properly, get it maintained properly, and then that's all cost savings in the long run.
Right. We were talking a little bit about retrofitting homes, giving people an idea, right? Rough, this is, take your average home. It's not your specific home, but some idea of what do these systems kind of
do it
cost?
broadly.
Yeah, broadly.
Because we have houses that are 1,000 square feet to 4,000 square feet. So needless to say, the cost factor will be different.
Sure. And that's probably one of the biggest questions that we get is, what does it cost? So an air source heat pump for a single system, just one outdoor unit with one indoor unit that's heating a certain size space. It could be one room. It could be, a lot of these homes have great rooms now where everything is open, which is perfect because we can put one unit in that space. It ranges starting at $4,000 to $5,000 for one unit. And then it goes to, anywhere from more of the home to a whole home system. And let's give that a range of, 10 to 15,000.
Right.
For a geothermal ground source heat pump system, we usually say the smallest system is, 28 to 30,000, and then they go up to maybe 50 to 70,000. There are a lot more incentives available for geothermal, and depending on, those incentives and the size of your system, in some cases, the geothermal system is the same price or very close to an air source heat pump after these incentives and rebates. And so the energy savings, and even if it's a little bit more, a few $1,000s more, the energy savings is that much more that it will have a payoff.
Right.
Once you pay it off, it's all money in your pocket at that point.
Right.
Good point.
Just a reminder as we sign off here today that Jamie is at website, please.
alpineaironline.net.